Okay, so continuing our examples in 5.1, let's try to finish up these examples. You have a certain type of bacteria that increases according to this formula, where T is the time in hours. How many bacteria are currently there? The number out in front will tell you what the starting bacteria is. So it started with that amount. How do you know? If you plug in a 0 here, okay, you end up getting 0 as an exponent. E to the 0 power, for those of you that don't already know, is a 1, and 1 times 100 is 100. So at time 0, before anything happened, that's how you know that it's 100 that went in there when you plug it in. How many will represent after 5 years ago? Okay, so 5 years ago meaning -5. What happened 5 years ago? So now I'm plugging in a -5. This is telling me that 5 years ago there was only 33.34 bacteria located in that area, and how many will be present in 5 hours? So 5 hours, it's a +5 that gets plugged in there instead, and they'll be 299.97. Now keep that in mind. In the course of 10 hours, it went from 33 bacteria to 300 bacteria. That's how quickly this stuff increases. That's why it's such a drastic problem with certain diseases that exist, because if you can't find a way to stop or prevent them, they will go up so fast and so quick. That's the drastic course of life, I guess, of worst case scenarios, but hopefully that doesn't happen. Here you have e's on the bottom together, so you just set the tops equal to each other to solve. Well, because I see that it's a quadratic, I'm going to get my x's on one side and my number on one side and see if I can factor it, which surprisingly enough you can. A -3 and a -4 work, right? Because -3 minus 4 is -7. -3 times -4 is +12. So those are my factors, and when you go to solve it, you set each one equal to 0. Add 3 to both sides, so you get 3 as an answer. Add 4 to both sides, so you get 4 as an answer. So what will make that work? If you plug the 3 in or you plug the 4 in, either one would make those two work. Same here, set each of those equal to each other because the bases are the same. So it's 3x equals 2x minus 1. I would just move the x's and I get x equals, sorry, it should be a -1 there. There we go. -1 as our answer because we just get x equals -1. Just to graph that, you go to y equals, clear out everything you have in there. Press second ln, that'll give you e to the x. And when you go to graph, you get a graph that kind of goes up like an exponential growth. And there's your points, which you can go to second table, second graph, and that'll give you the table. So you can see that it basically is an exponential growth problem. E to the -x, though, what's that give you? So test that out. Go to y equals, and instead of being e to the x, put a -x in parentheses there. And you'll notice that e to the -x is actually an example of exponential decay. Notice how it's going down. So this is something to keep in mind. Remember, fractions in between 0 and 1, those are exponential decay. Numbers greater than 1, those are exponential growth. Well, e to the x is exponential growth, and e to the -x is actually going to give you exponential decay. And think about it. E to the -x, you can't have a negative exponent, so it's like saying 1 over e to the x. And that's really like saying 1 over e, all of that in parentheses to the x, because 1 of the x would be the same thing. But the point I'm getting at is it's a fraction, right? 1 over e, and we said e was 2.71 roughly. So 1 divided by 2.71 is about 0.36, 0.37. And if it's 0.36 or 0.37, that's definitely in between 0 and 1, so it makes sense as to why it's exponential decay. So to graph this, once again, just go to your graphing calculator, but if you remember your initial graphs of e to the x, then all you got to do is move all the points up 5. Because same rule applies, just move everything up 5. And this, just like the other thing, that would be your horizontal asymptote. Horizontal asymptote is now at 5, just like the exponential functions, that number there is also hanging out by itself, the horizontal asymptote. Up here, it's like saying, hey, take e to the x, but what makes that 0? A -4. So you can shift all those points that we had over -4. And once again, you could just very simply graph this on a graphing calculator to get your answers. Notice how there is no number out here. The horizontal asymptote is still 0 because there is no number out there. It just moved everything to -4. So if you have any other questions or concerns, please let me know. When you're graphing, just use the graphing calculator, okay? Don't make this stuff any harder than it has to be. Just make sure you're plugging the stuff in correctly and everything will be alright.